Hello. Okay, so this is Chemistry Honors Unit 2, Structure of an Atom by me. So this is a basic summary. We will be doing the summary and vocab before the video begins. If you'd like to skip around, go ahead. So, Unit 2 of Chemistry covers a wide variety of subjects, but is categorized under the phrase structure of an atom. In this video, we will cover Dalton's atomic theory, the structure of an atom, using atomic mass and number to find subatomic particles, ions and isotopes, electron configuration, and average atomic mass. John Dalton, way back when, created a theory for how atoms worked, but as technology advanced, different scientists have added onto this theory with their own discoveries. The structure of an atom contained 3 subatomic particles that make up the atom's number and weight. Using its number and weight, we can reverse calculate to find its number of protons, neutrons, and electrons. For some atoms that aren't neutral, they can have a different number of neutrons or electrons. These are called ions and isotopes. Electron configuration gives us the ability to try and pinpoint where an atom electrons hang out. Lastly, while finding different isotopes within atoms, we can use this abundance of those isotopes to find an atom's average mass. So, some additional vocab that might be useful. Atomic theory. So it says that all matter is composed of particles called atoms. Dalton. He was best known for introducing the atomic theory into chemistry. Thomson. He's credited with the discovery of the electron, the first subatomic particle to be discovered. Millikan. He discovered the elementary charge of an electron. Rutherford found the atom consists mostly of empty space with its mass concentrated in a central, positively charged nucleus. Bohr. He discovered that energy is transferred only in certain well-defined quantities. Electrons should move around the nucleus, but only in prescribed orbits. When jumping from one orbit to another with lower energy, a light quantum is emitted. Heisenberg. He discovered the uncertainty principle, which states that a particle's position and momentum cannot both be known exactly. Atomic symbol. Abbreviations used in chemistry for chemical elements, functional groups, and chemical compounds. The atomic symbol comes from an element's Latin name. Ionization energy is the minimum amount of energy required to remove an electron. Valence electrons, an outer shell electron that is associated with an atom. Natural abundance, the measure of the average amount of a given isotope naturally occurring on Earth. Principal quantum number, one of 4 quantum numbers assigned to each electron in an atom to describe that electron state. It refers to the size of the orbital and the energy level an electron is placed in. Sublevel, each energy level or shell is divided into sublevels, are represented by letters S, P, D, and F. So now that vocab's out of the way, we can start with Dalton's atomic theory. Dalton's atomic theory, an atomic theory created by John Dalton about how atoms are structured and how they work. It had 4 main principles. 1. Elements are made up of small particles called atoms. 2. All atoms of an element are identical to each other and are different from atoms of other elements. 3. Atoms of 2 or more different elements combine to form compounds. And 4. Atoms cannot be created or destroyed, only rearranged. As time goes on, some of these principles have stayed the same and others have been disproven. Example, it is close to the modern atomic theory, but over time there have been ideas of what atom is made of, such as the Bohr model. Structure of an atom. An atom is made out of protons, neutrons, and electrons. Protons are positively charged particles within the nucleus of an atom. Neutrons are neutrally charged particles within the nucleus of an atom, and electrons are negatively charged particles within the electron cloud, outside of the nucleus. The nucleus is the positively charged central core of an atom, consisting of protons and neutrons. As you can see on this image, on the outside in blue are the electrons, and the inside with red and gray are the protons and neutrons. An example would be helium. Helium has 2 protons and neutrons within the nucleus, you could see in red and yellow, and 2 electrons on the outer shell in blue. Using atomic mass and number. Atomic mass is the mass of an atom. The atomic number is the number of protons in the nucleus of an atom, which determines the chemical properties of an element and its place in the periodic table. In a neutral atom, the number of electrons is the same as the number of protons. To calculate, number of protons equals atomic number. Number of electrons equals number of protons in neutral atom. Number of neutrons equals mass number minus atomic number. The number of protons plus the number of neutrons equals the mass number. An example would be oxygen here, has 8 protons based on its atomic number of 8. Rounding its mass, there are 8 neutrons, since 8 plus 8 equals 16, which is its atomic mass rounded. And if it's a neutral atom, meaning its electron number is also 8. Ions versus isotopes. An ion are atoms of the same element that have the same number of protons but a different number of electrons. More electrons means it's negative, less electrons means it's positive, meaning if it gains an electron, the atom becomes overall negative, which would be an anion, in blue here, and if it loses an electron, it becomes positive, which is a cation, in red here. An example would be neutral carbon, has 6 protons and 6 electrons. Carbon positive 1 has 6 protons and 5 electrons, meaning it lost an electron. And carbon negative 1 has 6 protons and 7 electrons, meaning it gained an electron. Isotopes are atoms of the same element that have the same number of protons but a different number of neutrons. They have the same atomic number but different masses. An example here would be carbon 12 has 6 protons and 6 neutrons. Carbon 14 has 6 protons and 8 neutrons, and carbon 13 has 7 neutrons and 6 protons. Electron configuration. Electron configuration is used to predict where atoms are in orbitals. Electron distribution. An orbital is a mathematical function describing the location and wave-like behavior of an electron in an atom. S-block elements have 1 orbital and 2 electrons in that orbital. P-block elements have 3 orbitals and 6 electrons. There are 2 electrons per orbital. In the D-block elements, there are 5 orbitals and 10 electrons. And in the F-block elements, there are 7 orbitals and 14 electrons. Like I said, 2 electrons per orbital. So an example would be sulfur. If you go and you count for sulfur, you cross a line through each one, meaning that sulfur's electron configuration would be 1s, 2s, 2p, 3s, 3p, 4. Because each one counts for that. The s has 2, so it'd be 2, 2. The p counts for 6, 2, and then if you put the last one, we only used 4 in the last p, because if you do not use all of that electron configuration orbital, you just write the number that you used. So we used 4. So sulfur has an atomic number of 16. You see 2 plus 2 is 4, plus the 6 is 10, plus the 2 is 12, plus the 4 is 16. Now, if you want to write it condensed, we can use CO. CO's atomic number is 27, and we would use the noble gases. You go into the noble gases, and you start that in your written form. 4s, 3d7. So we start at the noble gas that it's closest to. Since it's CO, that Noble gas is Ar. Then we go down into this section here, the 4s section, count those two, and then we go to the 3D section and you count 1, 2, 3, 4, 5, 6, 7, which would be Ar, 4s, 3d, 7, since we didn't use all in the D section. That's electron configuration. And now, last but not least, average atomic mass. Average atomic mass is the weighted average mass of all the naturally occurring isotopes of an element based on the abundance. This is how we get the decimal number on the periodic table. How do you calculate average atomic mass? 1. Multiply the mass of each isotope by its percentage or percent abundance, and 2. Add the results to give the average atomic mass. So we're going to be using chlorine 35 and chlorine 37 for this example. So chlorine 35 has its average mass as 35 AMU, which is average or atomic mass unit, times 0.7533. Why is it 0.7533? That is because the average abundance of chlorine 35 is 75.33%. You move the decimal 2 places to the left. Once you get that, you get about 26.3655. Next, we have chlorine 37. Its average mass is 37 AMUs times 0.2477, or 2447, because that is the average abundance is 24.47%. That equals around 9.0539 AMUs. When you add those together, you get an average of 35.4194, and that's your average atomic mass of chlorine. Anyways, that's all I have for Unit 2 of Chemistry. Have a good day. Bye.